And this question is very similar to question 54. Find a possible equation for the graph below, and where we have a sinusoidal graph. And this time, let me use the formulas of the textbook. We copy this, put it here. So we will have to do a little bit of reverse engineering. So instead of starting from sine of x or cosine of x and getting our graph, we're going to start with our graph and figure out where it comes from. So let's find the vertical middle. That's easy. So the maximum is 4, the minimum is 0. So the vertical middle is right in the middle. Add them and divide by 2. Y equals to 2. And that's going to give us, and then we get to choose what function we want because of the cofunction property. Cosine and sine are shifted versions of each other. We saw that. I don't know, let's go with sine. Y equals to a sine bx minus c, and then plus d. And then that vertical shift, this is the graph of sine. And then let me mark the 5 points. So the vertical shift is 2 instead of 0. The vertical middle is y equals to 2 instead of y equals to 0. So the vertical shift has to be 2. And the amplitude is how much the function, the outputs deviate from the vertical middle. Instead of 1, now they're deviating by 2. So the vertical from, that's the vertical stretch. They're easy to find. The tricky part usually is going to be what goes into sine, the horizontal transformation. And for that, I suggest find the same shape of a sine curve, fundamental period of the sine curve, somewhere on the on your graph. Find where you start in the middle, you go up, you go down, you go down, you go up. That's going to be my fundamental period. And it's going to be between -2 and 2. What I like to do is in my solution of the previous problem, not memorize anything and just write where the period starts and ends, and then figure out what is between 0 and 2 pi, and that goes into my sine function. Alternatively, you can use these formulas. So the period is 2 pi over absolute value of b. And b, we can take it to be positive in this case, the way we chose our piece, right? We didn't pick reflected sine piece. We just picked the regular sine piece. Oh, reflected this way. Yeah. Like when I wrote that graph, it's horizontal reflection. Anyway, so we can assume our b is positive. So our period is, okay, where does my cycle start and end? Starts at -2 and ends at 2. That makes my period final minus start. How much did I move? 4 units. And my phase shift is where my period starts instead of 0. And from there, we can figure out B and C. So let's first find B. Period is 2 pi over B. And my period is 4 pi over B. That would make multiply both sides by B and divide by 4. 2 pi over 4, or B equals to pi over 2. And once you know B, you can use the phase shift formula. Phase shift is C over B. My B is pi over 2, and my phase shift is negative 2. Negative 2 is C over pi over 2. Let me make the fraction on the right nicer. Dividing by pi over 2 is the same thing as multiplying by 2 over pi. And then if I solve for C, so I will have to multiply by pi and divide by 2. And the 2's will cancel out, and minus pi will survive. And if you can remember those formulas, then you can write what B minus C would be. Pi over 2x minus pi, which is pi over 2x plus pi. And when I put everything together, y equals to a sine bx minus c plus d becomes y equals to, what was my a? 2. 2 times, 2 times sine pi over 2x plus pi minus 2. Let's see if this is one of the answers. There are infinitely many correct answers because of the period and cofunction properties. Possible correct answers. What do we see? The first one is our answer. Okay, it doesn't make it better than the other answers. They're all equally good. But we found it. Oh, that's not minus 2, it's plus 2. I'm sorry. Our D is plus 2, right? We shifted up. We found D to be plus 2. I just put the wrong sign here. And that's all I wanted to say about this question. If you want more examples or if you have questions, feel free to ask.